Okay, everybody, welcome once again to the basic post-processing class. We talked about a couple of things last office hours, and I just want to address some follow-up for some questions that were asked. Andrew wanted to know if I was going to cover machine definition configuration using the components to build and modify 4 and 5 axis generic posts for the Trunnion table. We can probably spend like an hour during our office hours going over 5 axis. The reason I tend not to do too much of it in this class is that we have a whole nother course that is designed specifically to cover the generic Fanuc 5x milpost. So we take the 5x milpost and we go through all of the configuration options. What I will do, because I know some of you, are that's currently what you're working on. It's always a challenge because you're expected to, you went to the post class, so you know everything about posts, right? That's the way that some managers assume that it works. And the reality is that learning about the Mastercam post language could literally, I could create a college course, a degreed college course around that, because there is so much information, so many different functions and techniques and things that you do. So what I am going to do is give you guys a copy of the generic Fanuc 5x post document. And this document is actually designed as a training guide. It's a PowerPoint presentation that is designed to be used by an instructor to take you through the generic 5x milpost and talks about how to modify the generic 5x milpost. There is a lot of information that you can gain just by reading the PowerPoint. There is some stuff that it's hard to just read it and understand it without having an instructor present it to you so that you can ask questions. So again, I'm happy to give you all a copy of it. If you've already got some post experience, it may just be the only thing that you need in order to get started editing a 5-axis post. We're not going to cover much of it in this class tonight. We're going to save it for office hours. What's the feeling in this class about the Wednesday-Saturday split? Do you prefer that, or would you rather just do 2 hours on a Saturday? Is there anybody that can't make Saturday that would prefer a Wednesday? Let's put it that way. Because if not, we'll just do 2 hours on Saturday. I'm getting them. I like Wednesday from Matt. Either works. Is there anybody that can't make it Wednesday if we did 2 hours on Wednesday? So let's put it that way. Saturday, 2 hours, good for John. Okay. Harder for me. You know what? Okay, so we'll split it. We'll split it this week. We'll do a Wednesday and we'll do a Saturday session. That's fine. So we'll do that this week. That's good. And it also makes it so we have class 3 days in a row. It kind of keeps the continuity. So we'll do that. That's fine. Okay, so in this guide, it takes you through the setup of the generic Fanuc 5x milpost. And Nigel, we did record them, and we are going to put those up on the site as well. So the generic Fanuc 5x milpost is a post where the majority of the processing logic for calculating values is encrypted. It is designed as kind of a black box where you can easily configure the type of post that you want to create by setting a bunch of numeric variables. With the release of 2018, they have taken some of these variables and actually hooked them into the machine definition. So in 2018, if you had a generic version of the post, you should be able to modify the machine definition instead of editing the variables directly. To me, it doesn't matter either way because the end result is the same. I suppose it's a little easier in some cases if you're not familiar with it using the machine definition. So this guide, and again, we're going to just go through it real quick, talks about how to set up the generic Fanuc 5x post using the variables. So this is the older guide. It was created around version 9. So for the last 15 or 20 years, we've had this generic post that would support basically any type of 5-axis machine, all by configuring the variables inside the post. So this walks you through setting the M-type variable to select the type of machine, gives you some examples. So 0 is table, type 1 is a tilt head table. It's where one rotary is on the head, one rotary is on the table, and type 2 is a head-head machine. The other types are nutators, and a nutator is where there is at least one rotary axis that is at a 45-degree angle to the other rotaries. It talks about setting up the rotary axis variables, which determines which axes you're rotating about. So in addition to M-type setting the rot axis and rot direction variables, basically do the heavy lifting for you. So using this guide, it goes through the rotary limits, limit types, talks about the offset options inside the post. So if you are already familiar with 5-axis and the generic Fanuc 5x mil post and you've been using it for a while, it's probably doable to just read this guide and do some tests. The problem is knowing what to test. So that's why we have a class that covers this specific post processor. So it goes through, all of the options that you would want for setting up the post, and kind of almost as important, it talks about how to use the miscellaneous integers. So the generic Fanuc 5x post, let me skip through a bunch of this stuff. This post is generic. So it's designed as a processing engine to be able to process Mastercam toolpaths, run it through some mathematics to figure out the kinematics, and output the code. A lot of it is just pure math-based, though. So it's not like it does any collision detection. It does have things like rotary axis limits that include wind-up. So it will detect if you're about to hit the limit, and if it does hit the limit, it will actually tell the post to retract along the tool axis vector, unwind the head, or the rotary table, if your machine happens to be a trunnion, and then reapproach the part along the same vector and continue cutting. In order to be able to access all of the power that's in the post, you have to be able to know what the settings do for the miscellaneous reals and the miscellaneous integers. So in this back here, it talks about what each of these miscellaneous integers does and a little bit about how to use them. But it's all very useful stuff. So talk about how and where to make customization changes in the post customization file. And then finally at the very end, it actually gives some slides that talk about typical machine types and the basic settings that are required. So if you look here, rotary table on trunnion table, here are the various settings that you would set for, a table on table trunnion. Here's for a Fadal case. So here you can see the first one is an A on C. The next example is an A on B. We got a tilt head, so this one happens to be a B or an A on B, so the A axis rotates on the B. The B is the primary. Gantry settings. So it's got a lot of really useful information in there. It's meant, again, to be presented by an instructor, and that's why I use that as part of my 5-axis post class to take you through how to set up a couple different types of 5-axis machines, how to use the miscellaneous integers and real numbers. So we actually cover what all that stuff does, and how to use it to control the post. And then we look at making modifications to the post. And one of the things that's hard for people to wrap their head around is that the PSB portion of the post, the encrypted portion, produces absolutely no output to the NC file. All the PSB does is calculate values. So it is possible to override any of the processing in that post if you know where to edit and how to edit. So again, we cover that in the 5-axis post class. Today we're going to talk about variables. Oh, sorry. Before I get going, we are going to look next office hours at making some quick modifications to the post. So things like outputting sequence number only at the beginning of a tool change. And we're going to look at MP master and talk about tapping. So how do we get different tapping controls? So right here, okay. So today we're going to talk about variables, and specifically we're going to talk about numeric variables. We'll probably spend all of class tonight talking about numeric variables, and then move on to string variables either at the start of next class or maybe even middle of next class, depending on how far we get. Okay. So numeric variables are used to store floating point decimal numbers, integers, and Boolean values, Boolean being true or false. Each numeric variable is identified by a unique label, the label being the variable's name. Some variables are predefined, so you do not need to declare these variables before you use them in the post. The names of the predefined variables end with a $sign character. Other variables are user-defined variables. These are created and declared by the post writer. Numeric variables can be used for values that are passed from the NCI file, values calculated in MP for a specific routine, switches that enable or disable posting options, user-defined variables defined by the post writer. MP also includes command variables. When used on a line by themselves, they trigger a specific routine in MP. So what are the predefined numeric variable types? First is the NCI variable. These variables are set by MP when it reads the NCI file. Typically, each value on the second line of each two-line pair is associated with a specific predefined variable. The NCI reference volume inside this portfolio lists all of the NCI G-codes along with the predefined variable assigned to each of their parameters. Calculated variables. This type of variable is set by MP as the result of calculations it performs on NCI variable data. Postswitch. Postswitches are initially set to a default value of 0 by MP. Many post switches are set in the control definition. Okay, what's an example of a post switch? If you go into your Mastercam file, and let's do this. Let's open up our other example. And you go to make a change here. And we go into the toolpath copy of our machine definition. So remember that when we load a machine definition into our operations manager, Mastercam loads a copy of the machine definition file and a copy of the control definition file into your actual Mastercam file. The reason being so that you can make file-specific configuration changes. For example, let's say we were having trouble fitting this program into our lathe. We've got an old lathe, it doesn't have much memory, and so we want to make a program that's really nice and compact. We might go into the control definition through the machine definition manager here, and this is, remember, this is the file copy, so it's actually stored in our Mastercam file. And now we go to NC output. Output sequence numbers here is a post switch. So it gets initialized to 0 by MP when MP starts up. And then MP reads the control definition. Technically, MP fires up and it creates the variables. Then it reads your post file. Then it reads the control definition file. And based on the settings in the control definition, these settings override or set those post switches. So now we're looking at the condition of the control definition file that's stored in your Mastercam file to determine whether or not output sequence numbers is turned on. Sequence number output sets a variable called omit seq, or omit sequence. And if it's set to 1, sequence numbers are disabled. Oh, excuse me. Yeah, if it's set to 1, they're disabled. If it's set to 0, they're not disabled. The same is true of spaces between NC addresses. There is a predefined variable called spaces $, that will be set based on the setting in the control definition. So if I really want to shrink my code, I can make the spaces 0 and I can turn sequence number output off, save it. That saves to the toolpath file copy. Do a quick regen. And when I post, now sequence numbers are turned off and there are no more spaces between my NC addresses. And so this file is now 2,671 bytes. If we go change those settings back, it may not be a lot, but it'll be enough, hopefully to let us fit this NC file into our machine's control. It's just one of those things that we can do to save space if necessary. So let's reset this. So we got a question, is there a switch to output any G code on separate lines, like G00 or G90? Not by default, no. There is now a generic Heidenhain post processor that was pretty much just released. I don't know if they're including it with the default product install or not, but for Heidenhain, I would look there. I don't know if they've automatically done that already to their Heidenhain post. I would hope so, considering it's supposed to be the generic starting point. But not by default, no. What you'd need to do is go in and edit the post file to do that. And you would either, you could set it up with a switch if you wanted, but you'd need to take each output line and essentially break it with an if-else statement where you had, if your post is Heidenhain, do this. If it's not, do that, So we can certainly take a look at that. Oh, and if we look at, did I repost? I haven't got that far, have I? No. So repost. And it went from, 2,700 bytes to 3,600 bytes. So almost, a 25 or 30% increase in the size of the file by adding the spaces and adding the sequence numbers. Jeremy says there's a generic 4x Heidenhain in the additional 2018 Mastercam post download. Awesome. That's good to know. Jeremy, if you have a copy of that download and you can send me a copy, I'd appreciate it. Just another thing that I'd love to share with the students. It's weird. I have a Mastercam, not developer. It's like a Mastercam partner HASP, which, funny enough, doesn't allow me access to the regular Mastercam forums. It's silly. I'd have to have a customer HASP to get access to the customer area, which, God forbid I'd want to help make the product better, The problem, Jeremy, is I can't download it from Mastercam.com because I don't have access to that area. I've only got access to the Mastercam partners area. So, I can go get the SDK, which is... Oh, thanks, man. Appreciate that. I can go get the SDK, which would allow me to, write C-hooks for Mastercam, but I don't have access to the current, post area. So, but I appreciate that. Okay. So, variables. Constants. There is a post variable type called a constant, which is meant to be a variable that is uneditable. But then there's a note down here. Let's see what we got here. Hold on one sec, guys. So one of the first things to say is that, a constant is designed to be a value that's not changed. But then it tells you a constant in the MP language is not protected in any manner. Be careful not to assign a value to a constant or use it in a formula that can modify the value. I don't know truly whether they have changed that and they are protected or not. So what we're talking about up near the top of most post processors, that's the generic Fanuc 5xml post as an example. There is typically a set of variables. Let's turn off the white space. There's a set of variables that are set up and defined as constants. And this is a bad example because it's an older version of the post. So let me go to grab the generic Haas 4xml post. Constants are typically initialized with the colon equals. Normally when you initialize a variable, it is done with the colon sign. And this sets the initial value for the variable and for the previous value of the variable. The colon equals is supposed to make it so that the value of the variable doesn't change. So FIVE, for example, will always be defined as the number 5. FOUR will always be defined as the number 4. But then they give you this little bit of information saying that this isn't protected in any way. So if you actually had some logic that tried to modify the value of FOUR and you set it to 25, and then it was used somewhere else in the post, you would essentially be able to break that logic. This was done as a way to try and deal with one of the problems in MP. And one of the problems for a long time was that the way the language was built, there were only two types of variables. There were string variables and there were numeric variables. And numeric variables carry overhead in processing terms. They take up space in memory. When you create a variable name, Mastercam actually creates 4 distinct memory slots that are associated to this variable. There is the current and previous value, and then there are the extended current and previous value. The reason being that you can do some kind of advanced level mathematical things with these types of variables, the extended set. I've honestly never used extended variable options because they haven't been around that long. So MP has been enhanced for a while now, and we've finally added some new variable types. And we'll get to those in just a sec here. Okay. Hold on one second, buddy. Actually, you know what? This is a good time to split the video anyway. So we'll go ahead and split the video, and we'll start up a new one in just a sec.